All right, we're going to try this again because the other video didn't work. We're going to do the 10-2 practice problems. I picked out some to do. Remember, you guys should be working on this quiz that I sent out on Friday. Those of you that picked up the packet will be getting this one done. It should be done for tomorrow so that we have some due dates. So, number one, have that ready to go. So this should help also with that quiz. We're going to do 4 problems from 10-2. You can check your work against that. Some of you have been sending your work to me. Great. So we're going to do number 4. Okay, I'm just going to go through them and how I set them up, just like we do in class. So we have, number 4. We have 362.8 grams of C5H12, and we need to figure out how many moles of C5H12 there is. Again, good practice. Try to name these things that we're working through. Go back and look in your notes. This is a hydrocarbon, just carbons and hydrogens. This one would be pentane. Okay, 5 carbons, 12 hydrogens. So this is actually just pentane. We'll call it that from now on. We know from our notes that 1 mole of a compound is its atomic mass weight of all the parts that are making it up. So we have 5 carbons and 12 hydrogens. We look on our periodic table and we add up 5 times 12 plus 12 gives us a total of 72 grams of C5H12. That gives us our molar mass, grams per mole. We then plug this into our dimensional analysis process. 62.8 grams C5H12. Do our conversion factor. 1 mole C5H12. 72 grams C5H12. Again, cancel things out. Some of you that have been sending me work, get little notes back in your emails about showing your work. I need to see work, guys. If there's no work, just like you didn't do it. We plug in our numbers. We know we had to have 4 sig figs in our answer, so you should have came out with 5.039 moles of pentane. Okay, so that was number 4. There's a quick one-step problem. Again, we use our periodic table to find our molar mass, and that's going to be a common theme from doing these things, especially when we got to deal with mass. Okay, so that's number 4. Okay, you rewind that if you need to. Our next one is going to be number 11. This is the one that I cut out on apparently last time. And this one we're going to take 1.25 moles of oxygen. Remember, oxygen is a diatomic element. That's something that comes into play here because it wants to know atoms of oxygen. Okay? Atoms of O2. Okay? That's going to be a big deal. So we know that 1 mole of oxygen is equal to 6.02 times 10 to the 23rd molecules of oxygen. Remember, this is a diatomic element. It's a molecule. So we go from moles to molecules. Now, we actually need to get to atoms. So we know that if I look at the formula, we know that for every molecule, so I can write 1 molecule of oxygen is equal to 2 atoms of oxygen. Okay? 2 atoms of O2. Do it that way. This is actually a 2-step problem, number 11 is. So 1.25 moles. We have our 2 conversions. Get rid of moles first. 1 mole O2 is 6.02 times 10 to the 23rd molecules O2. Next, you got to write out the whole word molecule. Because 1 molecule of O2 is 2 atoms of O2. Molecules cancel out, moles cancel out. Again, I go back up and check 3 sig figs in my answer. So you come out with 1.505 times 10 to the 24th, and it should be a pretty big number. You know, if we're looking for particles of something, that should be a pretty big number. And this will be atoms of oxygen, and I ran out of room there. I'll move it over. 3 sig figs, though, I have 4. So the right answer is 1.51 times 10 to the 24th atoms O2. That's a 4 there. Okay, that's number 11. Okay, now hopefully you got through that one. Okay, next problem is going to be number 18. Wish I had a big board so I could just leave them all up there, but I don't. This one here is looking at formula units. And we're going to shorten that up to the word units. This is titanium oxide. Actually, you should be able to even tell me the name of this one. It's actually titanium 4 oxide. We want to know how many units or formula units of TiO2 there are. So this one's going to be grams to formula units. So if we look at our little key, remember we had mole in the middle, we had particles, I'll just call it parts. Over here we had mass, and down here we had volume. So we're starting here, and we're doing a little pathway. We got to go through the mole to the particle. So we got 1 mole of titanium 4 oxide is equal to how many grams of titanium 4 oxide? Well, I look up titanium on the periodic table, add that to 16 times 2, which is 32. This comes out to be 79.9 grams of titanium 4 oxide. We know that 1 mole of titanium 4 oxide is equal to 6.02 times 10 to the 23rd units. Let's just shorten formula units to units of TiO2. And again, this is a ionic compound because it's a metal and a non-metal. That's why we use the word units. We then plug this into doing our dimensional analysis. 2 equalities gives us 2 conversions. 5.1 grams TiO2. 1, 2. Get those in there. 79.9 grams TiO2 is 1 mole TiO2. Grams cancel out. 1 mole is 6.02 times 10 to the 23rd units TiO2. Moles cancel out. 2 sig figs in my answer, so I'm just going to get the answer for this one. It should be 3.8 times 10 to the 23rd. Can't read my own writing here. Units of TiO2. Now, this does come out to be 3.84, but again, I can only have 2 sig figs. Circle your answer. That's number 18. And then we'll do the last one, number 30, because everybody always thinks the last problem in the worksheet is always the hardest. And those last set of problems were all dealing with volumes, going either moles to volumes, mass to volume. 30 is just a very easy one-stepper. We go from 138 moles of H. Don't have my eraser on me right now. Mole HBr is equal to how many liters of HBr? Now, what's nice is that just like we have 6.02 times 10 to the 23rd here for Avogadro's number, when we go to a volume, we have a given unit. We have a equality or a value that is recognized, which is 22.4 liters for every mole of something. Okay? So when I look at this, I go, well, I got to go liters to moles. Well, I know that 1 mole of whatever I'm dealing with, HBr, hydrogen bromide in this case, is equal to 22.4 liters of hydrogen bromide. Oh, too many H's there. Okay? So again, this is just one equality. We're going to go from moles to liters. If we needed to go to grams or anything else, we could do that too. But we only need to answer what it wants us to answer. So 138 moles hydrogen bromide is going to be 22.4 liters of HBr over 1 mole HBr. Moles cancel out. I look at my problem. I got 3 sig figs. My answer can have 3 sig figs. So you come out with 3,091.2 liters of HBr. But again, 1, 2, 3, 4, that's 5 sig figs. It can only have 3. So we got to remember to hop backwards, do the whole little bunny hop thing again. 3.09 times 10 to the, what, 1, 2, 3, third liters HBr. And there you go. Things that we've done all year long, we're still doing. Okay, we're going to keep doing this when we get into the next chapter. The quizzes that you've been getting since Friday, and those of you that picked up the packet and got the 3 stapled together already, those are what we're working for and getting ready for our test over this. I'm not sure if we're going to get to the test this week or not, but we'll see. Okay, we'll just keep working through this. Keep emailing me questions when you got them and showing me your work. The grades are, counting. Enough things have been sent out to you. I know you can get your work. We'll talk to you later. I'll be sending a new one out tomorrow on doing empirical formulas and percent composition. We'll do an example from your 10-3 practice problems, which you're also working on for this week too. Okay? We'll talk.